examinations in which the authors who send papers to our journal, will go through to try to make a silver purse out of a sow's ear. And I'm going to talk about some of those, and I guess, how does this work? All right. Whoops, that's not the, there we go. Somehow. That's the title, that's the original title. I came up with a second title. I thought about this with apologies to Isaac Newton and Dame Juliana Berners, who wrote the first treatise on fishing with an angle. And I think that we get papers from authors every day who are fishing with an angle. And this has been going on, I think, since she wrote that treatise in the 15th century. We start with the normal things about disclosures, and I point out that in my youth I was guilty of everything I'm going to talk about, but I learned something along the way, and hopefully I'm not guilty of these things anymore. And then, I've consulted and received money from governments, all sorts of NGOs, various food companies and the like, so I'm totally conflicted. So the first thing I want to talk about is, should the study or the paper be there in the first place? And what I've discovered is that however implausible or unsupported by any data, an hypothesis can be constructed to connect any nutrient to any clinical outcome in 6 steps or less. And whatever the nutrient is, okay, can be connected to this nutrient, to that outcome. And there are absolutely, frequently we get a massive number of papers, that provide conclusions for which there's no, clear connection in any direct scientific way. And that's just sort of a philosophical statement rather than, it is a problem, but it's more of a philosophical statement. So the first thing I want to talk about is the people who are shooting craps in a chanceless casino. There's no random, odds in a chanceless casino. These are the groups of studies in which individuals will get a positive answer irrespective of whatever happens. So as Stan Young is very fond of pointing out, how do you assure that your study will at least have one positive result? And as Stan says over and over again, you ask a lot of questions. If you ask 61 or more questions, you have a 95% chance of a positive study at the P05 level. And this is a particular problem in observational studies, which, as far as I can tell, the nutritional epidemiology community, views with scorn or disdains the fact that they have now done so many observations that the likelihood of some associations being positive at the P05 level due to chance is the rule rather than the exception. So the example that Stan has actually talked about is the study that appeared in JAMA in 2012 on vitamins and the prevention of cancer, in which there were 15 questions and 21 outcomes. So 315 different hypotheses were tested. So the likelihood of finding some associations by chance was a given. The second sort of extension of that is what Robert Abelson, who wrote a wonderful book that David put me onto, Statistics as a Principal Argument, is his second law of statistics. And his second law of statistics is that overconfidence abhors uncertainty, meaning that if you know the answer and you're a confident investigator, you will find a way to make sure that there's a positive, that you can come to a conclusion. And recently, Simmons, published in the psychological literature, another very interesting paper in psychological science. And in the paper, he said, when faced with ambiguous analytical decisions, researchers will tend to conclude with convincing self-justification that the appropriate decisions are those that result in statistical significance. And he presents a variety of the psychological arguments why this is so, and this is something which we see almost every day. And in fact, in that paper, they calculate the likelihood of obtaining false positive results with simulations of data. So in this case, they had 15,000 simulations in which 21 observations per cell were the initial condition. And this is a complicated slide, but the principal point is that if you look at the center column where there's a p of 0.05, that you can, what Simmons calls this is the researcher degrees of freedom. That is how the researcher can alter the likelihood of finding a p of 0.05 or less by the way that they do post-hoc analysis of the data. So if in fact he starts with situation A where there are two dependent variables, and I believe he did 3 t-tests on these 2 independent variables, one on each of the variables, one on their combination, there's something like a 9.5% chance, if the relationship is, if R is 0.5, of showing a significance at p of 0.05 level. And then as you do additional things like correct for covariates in different situations here, for example, where you do different permutations of corrections for covariates, you can raise the probability of finding a p of 0.05 to levels that essentially guarantee that you will find something positive by how you decide which covariates you correct for. And this is never, ever, at least in my mind, discussed in any of the observation literature. Then there's another variant of this, which I call shopping in the tile and carpet store. So the first one is the analysis of data by what I would like to call my tiles. So the authors don't tell you, but they tried tertiles, quartiles, quintiles, deciles, their tiles and your tiles. But the only tiles that worked were my tiles, that is the author's tiles. They don't let you in on any of that, and if you look in the HACN, you will notice that some data sets are analyzed as quartiles, some as deciles. Very rarely is there any objective reason for making those decisions that you can discern with any clear reason. The second part is the carpet store, where you put under the carpet, everything that didn't work. You sweep it under the carpet. So there are, rarely do we find anyone who mentions in a paper the total number of analyses done. Okay, so you have some idea whether what you've shown, okay, represents a minor fraction of what the authors actually did that didn't work. Okay. The other rather remarkable thing is that the primary endpoint in a paper is frequently either unmentioned because it, quote unquote, didn't work, okay, or it's completely buried in the paper. So it may show up as one line in table 6 or table 10, kind of unannounced. Or, there may be a casual mention 3 sentences before the study ends, oh, and the primary endpoint was negative. But the entire rest of the 1,500 lines of text or something is based on something else in this particular study. The one that's several of us here have spent a lot of time looking at is implying causality from associations. And this may be hard to see this in there, but I was trying to reduce the number of slides. These are some of the more famous ones that I found recently, in addition to the classic association that Helmut Sees published back in Nature in 1988, where he showed that the number of births was related to the number of storks that were roosting in part of Germany. Okay, so clearly, storks are responsible for births. Here we have the association between the increased prevalence of obesity and the consumption of regular soda, which of course is, the problem. The only problem is that it's also associated with the consumption of diet soda and with severe hurricanes. Okay. This is from one of David's, and I think Andrew was on that paper, I'm not sure, slides showing that the prevalence of obesity is associated with the increased prevalence of drinking bottled water. Okay. This is a famous one from the New England Journal about 2 years ago that showed the relationship of chocolate consumption to Nobel laureates in different countries. Okay. Here is one showing that this is the prevalence of alcohol so the alcohol consumption to the number of clergy in a country. Okay. And then finally, a recent one that someone pointed out is the relationship between the increased prevalence of autism and the sale of organic foods. And the message here is that the good authors of observational studies, if pressed, will always say to you, of course, I'm only showing associations. But who, including them, would be interested in those associations if they didn't think they were causal? So they imply causality as much as they can, and I think one of the principal jobs of editors in the AJCN is trying to remove statements of causality, and as David has pointed out, we're successful a lot, but we miss some because we all have day jobs. And the press is particularly problematic when it looks at implied causality with associations. The other issue is what I like to call the misdirection. This is the whole principle of magic X, right? Is I don't have anything in this hand, but all the action is going on over here. So this is a extraordinarily common approach. All the primary endpoints of a study are negative. 5 of 6 of the secondary endpoints are negative. But the entire text of the paper, the abstract and conclusion, are focused completely on the 6th and only positive endpoint. And it's important in this context to always read the registration document to find out what the primary endpoint is, because the authors frequently don't bother to tell you. And then there's the issue of bait and switch. So if one goes to the primary registration document, you find out that the primary endpoint was X and the secondary endpoint was Y. But the manuscript talks about the primary endpoint of Y and the secondary endpoint of X. And you find out that during the course of the study, the secondary endpoint was elevated to a primary endpoint, and the primary endpoint was demoted to a secondary endpoint. Now, I don't want to make any assumptions, but I will. Is it possible that during the course of the study, someone was looking at the data and noticed which ones were going to work out? There's actually, at least one study confirming the nature of how these endpoints migrate. And then there's what I would call the publication delicatessen. This Katz's rule. Katz's rule says that no matter how thinly one slices, and irrespective of the number of slices, a salami will always yield one more slice. And my corollary of that is that the more papers that you can publish from a single study, the greater the chance of hiding its faults. That is, which one is the primary endpoint, how many total number of observations there are, and whether or not there are inconvenient inconsistencies that one doesn't notice when the data is split up into multiple little pieces. Then there's the issue of animal studies, and this validity of animal studies that are extended to humans. And I think all of you know the old quote that no rodents are humans, but some humans are rats. But no rodents are humans. And in addition to the obvious species difference, animal studies have recently been highlighting great deficiencies of the most elemental conditions that would get them bounced out of the AJCN without a review. Issues of randomization, blinding, allocation concealment, use of intention to treat analysis, fundamental things that are necessary to even get a paper reviewed in good clinical journals. And recently there was this was an impression, frankly, but recently there was another publication that just came out in January on what authors are, have authors responded to the publication of guidelines for research reporting of animal studies. These are the arrived guidelines that come from an organization in Britain whose name is complicated and I can't remember what it is. These were published in 2010, and the authors looked at 2 journals, the PLOS journals and Nature, to look at whether or not authors are actually beginning to comply with reporting guidelines of animal studies. And what you can see here, if you can read it, is things like allocation to group and blinding, estimation of sample size, or power, for both of these journals in animal studies are remarkably low and haven't really changed basically at all since the publication of reporting guidelines. These are serious issues in the animal literature. And then we have the media, and this is an actual picture from a website of an Australian news agent, 7 News Adelaide. And the story is titled "Pregnant Women Urged to Avoid Junk Food." Now, I found this because this study was referred to in the New York Times. So you go to the page, and there's this wonderful pregnant woman, and pregnant women are urged to avoid junk food. Expectant mothers, mothers are being urged to steer clear of high-fat and sugary foods or risk that their child, being born a junk food addict. South Australian researchers have found women, who overindulge during pregnancy are more likely to deliver kids with unhealthy cravings. This is reporting a rat study. This study, there's no human beings in this study at all. Now, you can blame the reporter, but the first author of this paper in the same Australian release talks about mothers and children. This is a very significant problem. So where do we go from here? These are just some of the examples that I got off the top of my head, and I told Susie that if I had to give an hour talk, I could have gone on. So where do we go? The first thing is, I think that we absolutely need all journals to say you're going to register all studies before you start them. And this includes observational studies. The people who do observational studies are fighting this tooth and nail. We need some explicit declaration of endpoints, and registration documents today include naming the primary and secondary endpoint, but they don't police that so that they're named in a way that you can actually test the hypothesis, meaning the declaration of the endpoint is explicit so you know at the end what it was. You also need to have a listing of all the variables collected, everything that's collected, both in the registration document and in the manuscript, so we know how many hypotheses were tested and why we're not seeing 8 measurements that you said you made but don't show up anywhere in the paper you submitted to us. Usually, in my estimation, because they didn't work out. You need some kind of explicit a priori declaration of the data analysis plan, and particularly in the manuscript, at least, you need to provide the alternative data analyses plans as supplemental material. Now remember, in the old days, when you had to put it in the paper, it became a problem because you were trying to stuff things into contracted pages. Now you can put all this information on the web, and you need to include the analyses that were done with and without different kinds of data that were excluded, different covariates and different alternative models. Because rarely is there one model that is the only unique solution. You need to make, authors need to make the original data and the protocols available to referees and editors. There needs to be mandatory use of the different reporting guidelines, and we're going to hear about those later, so I'm not going to spend time on them. And then we need to, journal editors need to start requiring perspective in reporting. That is, the use of confidence limits instead of p-values, the discussion of what the absolute risk is, not just the relative risk. What is the fraction of the variance that these associations are actually responsible for? It's not unusual, it's 3% of the total. And things like the number needed to treat. How many people would have to do X to get, an effect? So in the end, I would use Frank Davidoff's quote to say where we are. So he said, 14 years ago now, accurate, transparent reporting is like turning the light on before you clean up a room. It doesn't clean it up for you, but it does tell you where the problems are. Thanks.